I'm John Yurek. I am a developer at and one of the founders of Thoughtbot, and this is a talk about naming. So if you get nothing else out of this, what I want you to remember is that all of your names you shouldn't name something for what it does. You should name something for why it's there. So here we have an if statement that it's a little contrived, but I'm sure all of you have seen something of it or possibly written something like it. So we're checking to see if there's a bunch of comments and when it was created, and if that's true, then we put it on the homepage and people's activity feed and all that great stuff. Now there is one big problem with this, and that is that the logic for determining whether or not something is a recent popular post is in the if statement. So if we extract that into a method, then that lives in one place. You know where to go for it. And it cleans up your if statement. So, and it tells you why that check is being done. Why, like what that the comment length is greater than 5 and comment last is created at less than 2 days ago, what that even means. Now, if everybody did this in all their code bases, that would make me really happy, because that would just clean up so many weird cases and so many questions as to why things even exist. It would make you and your coworkers happy. Now, here's the quote that prompted this. There's only 2 hard things in computer science: cache invalidation and naming things. And the reason that both of these are hard is because they are not calculable. There is no algorithm for naming something. There is no algorithm, well, no good generic algorithm for cache invalidation. There are ideas. There's what's best in this case, but there is no set way of doing it. It's something you actually have to think about, because code is communication. So when you actually write code, you're not just talking to the computer. You're not telling it what to do. Well, I mean, you are, but more than that, you're talking to your coworkers. You're talking to yourself. The computer doesn't care about names. All right, you can name your user class whatever you want, and everything will still compile as long as you're all referencing the same things. It just cares that everything lines up. If you name your post model Buffalo, it's still going to work as long as you call it Buffalo everywhere. And so as to prove this is actual code that one of my coworkers used to work on. Computers run this. Like, this is code. People wrote this. This is an executable program. It doesn't look like there's anything there because it's in a language called whitespace. This, I swear, and you can look at the Git repo where these slides are later, this is a running program. It will print out hello world. I mean, it's not all that big, but it runs. This is a language called brainfuck. There is a better intent to brainfuck than just fucking your brain. It was intended to put a Turing-complete language in as few symbols and operations as possible. And that's the thing, is that Turing-complete languages can all do the same things. Ruby can do the same things as whitespace, as that first language that's terrible that people actually have to use. But it just shows that languages are written for humans, because all of those can do the same kinds of things as long as they're Turing complete. They can run and do all the same kinds of operations. The interface for the computer and you is the language. So the reason that you want to write a good program is not, some kind of intellectual purity. I mean, maybe you do, but that's not the real reason. The real reason is that you have to deal with other people. Everybody is on a team. Even if you're not, like you're solo, you're still really on a team with yourself in 3 months. Because 3 months from now, you're going to look at some code and be like, what the hell was I thinking? And if you name things well, you'll probably ask yourself that less, but you still have to ask yourself that. What you need to do when you name something is reveal its intention. Reveal why something is there. Reveal the point behind the code. Like you're writing the code for a purpose. You need to reveal that purpose, reveal that intention. A name has power. Like a user class is just a user. You expect to log in with it. But an admin class, well, that's got some gravitas to it. That's you expect that user to be someone who could do things, get things done. This is the Sapir-Whorf hypothesis. Basically, I mean, there's a lot of text there. You can read it if you want. But the gist of it is the way you think about things affects the way you think about things. Like the language you use to think in affects how you think about them. So someone who speaks only English is going to think about things differently than someone who speaks French. Someone who speaks Esperanto is going to think of things differently than someone who speaks Japanese. It's just that's how things work. So when you think in Ruby, you're going to think differently than you think in Go. You're not going to think as concisely. You're not going to use single letter variables. And because of this, if you create a domain language, like the language that the problem is specified in, if you create that language, you'll be able to think about it. You'll be able to communicate it. You'll be able to speak with your coworkers concisely and exactly, and it'll make communication easier when you're going through all of this. Putting a good name on something after you come up with this domain language helps you reason about and think about the concepts that are in your application. But what you need to do is be specific. All right? If you can't name it, it's probably wrong, because in a lot of cases, you're often too generic. Don't be too general. Don't be too generic. If you have something called, let's say, I'll get to that in a second, but single responsibility principle applies to names. There was a program, or a project that I was working on, where the base class of all of these different services, like they would get data from Twitter, from Facebook, from whatever, but all of them had the same base class. The base class was called datum. Now, I don't know how many people actually know this, but datum is the singular of data, which is just like saying, oh, this object holds stuff. I mean, what good is that? What does that actually tell us? I mean, it's separate from object, sure, but it doesn't actually explain the point of it. It turns out that the datum object persisted to not only the database, because it was descended from active record, but it also persisted to Cassandra. So it did a whole bunch of crap that you would never have known from just the fact that it was called datum. So if this was named less generally, then maybe you would know that stuff was going on. If it has one function, it's easier to name. Like you can name it that thing instead of trying to name something that like it logs in and prints out that it's logged in to the log. Yeah, you can do that, and maybe it gets covered by one name, but it's going to be easier if you just have one thing that logs in and you call it that. So I'm sure everybody's familiar with Sandi Metz's rules at this point. Here they are, although we only really care about the top two at this point, and there might be some modifications in that. But the classes can be no longer than 100 lines of code, and methods can be no longer than 5 lines of code. That's the really important part here, because when you extract things and you when you have classes that are that small, when you have methods that are that small, then you get a lot of them, because you still need to cover all of your features. You still need to write all that code. I mean, we're not dealing in trivial code bases, so all of that code still needs to be written. It still needs to be somewhere. But the good part about having a lot of them is that you get to name them. The parts become labeled. And that means that the thing that syncs your contacts with Facebook or Google or whatever will have one name. And it will be labeled, and you will know where to go if you ever need to change that. So in order to do this, and what Sandi's rules promote is that you're extracting things. You've got your 50-line method. You break it down into maybe 50 other methods that do the things that you need to do, but are somewhere else, have better names on them, and are the definitive place for that bit of logic. So when you have a large method like that, and this is one of the things that I do in every new project, every new existing project, I'll go through and see this terrible controller action. I'm sure everybody's seen one of these where it's like 50 lines of code. You're like, who wrote this? Who tested this? Is this even possible? I mean, clearly there's no test because I can see that there's not, but you wouldn't have been able to test this in the first place. So what you want to do is learn how it works, because just looking at it is usually pretty confusing. So learn how it works by taking the code in there and extracting it out. Take 1, 2, 3 lines, pull it out, put it into a private method, and give it a name. And then when you extract that, you know why it was there. You know the variables that went into it. You know the variables it's using, what its return value is supposed to be. You can see why it was even in that method in the first place. Once you know the intent, then you can apply a good name to it. And then once you have good names on everything, and that controller action that used to be 50 lines and was clear as mud is now 5 lines, and at least you can read it and know what it does, even if you don't know exactly how it does it. But once you have that, you've documented the system, because that method now goes goes to other methods that have good names on them, and those names tell you what they're supposed to be doing. And in this way, the code can tell a story. Like when you can start out with a method at the top of the file. It doesn't necessarily work specifically well for actions, since there's 7 of them. But in your model, you can have or a class that it's single responsibility. So you have one method at the top that actually does all the work, and it farms out to other methods that are later on in the class that are more specific in their function. So you start at the top and have less specific things that it's just like, this is what it's supposed to do, and this is why it's here. And then later on, you actually do those things. So this code is from Paperclip. It's a plugin I wrote a long time ago to attach a file to an active record model. And this is a refactoring that 2 of my coworkers did. This specific method is from the hasAttachedFile class. Now, you can look at this and see exactly what it's doing. There's more than 5 lines, but that happens. But you can see exactly what it's doing. Like, these are the things that need to get done in order for Paperclip to work, in order for something to be able to accept an attachment. Now, what it used to look like is this, which is much longer, much less clear, and it's just harder to read. I mean, you could I'm sure everybody in this room can look at this and know what it's doing, but you have to read it and figure that out. And even though things are done in specific places, the getters are all defined in one place, the setters defined in one place, all the callbacks are in one place. It's not as clear as this. This is way clearer, because you can see these are the spots where stuff happens. If I want to see how the callbacks are done, I don't have to go here and try and figure out, oh God, where are the callbacks? I can just look here and say, oh, it's an active record callback. I'll go to that method. And in this way, your names need to make sense. Like if you name something, or if you have an array of users and it's called foo, that's not going to help anything. So because Ruby isn't statically typed, we do need to explain things a little more. So the array that I just mentioned should be called users, because there's there are users in it. And because we're usually dealing with active record in Rails, it's pretty often that you can do like a user.all and get all of your users into that array, and it's really not going to be that big a deal. But if you're looping through an array of something else, like say a YAML hash, and you're trying to find everything that's greater than 30 for whatever reason, you might end up with strings because Ruby isn't statically typed, but it's strongly typed, but it's not statically typed. It's dynamically typed, and things could just show up. So it helps to name things the way that they are going to be used or what they contain in a useful and informative fashion. So an array called users should contain users or some subclass of user. Don't name a variable x. If anybody's named a variable x and has used it for any length of time, and then they need to go and find that, that's going to be really hard. The worst thing you could do is name something C, simply because A and B were taken. Interestingly, that is how the C language got its name. But don't do that, because there's no context there. There's no way to know what C is, why it's there, what it contains. You can talk about it with your coworkers, and they can be like, yeah, OK, sure. And they won't get any information from it. Someone looking at that code would be completely lost. So what you want to do is make sure that because you have good names, you can let the names document the code. Now it's a little better than writing comments, because with a comment, usually it's in some darker gray color in your editor, or something that blends into the background. You're probably not going to see it, and they're not going to get updated. I mean, who actually likes writing comments? So what you can do is your variables, your method names, your class names, they can actually be the documentation. Like people talk about having self-documenting code, and other people laugh at that because they probably don't write good variable names. So if you have a good API, a good set of local variables, you'll know what stuff is supposed to go where and why. So this was something that we pulled out, or I pulled out of a project that we worked on. I don't know why this is called venue options, because clearly there's no options being passed, there's no options being returned, there's not even any options being used, really, because I mean this categories is a method, neighborhoods is a method, the active record relations probably, and like this is not an intention revealing name. So, but the thing is that doing it right is very small. Venues. Instead of venue options, it returns venues, because this is actually what it returns now. So it's very small. It's not like a big pomp and circumstance thing. Just name it what it's actually doing. I hear some chuckles. I'm sure people have run into Hungarian notation before. If you've been a programmer for a while, you may have seen it like in Java or C# or whatever. It popped up on the daily WTF quite a bit because of the stupid ways it gets used. There are actually two different means of Hungarian notation. Well, first of all, Hungarian notation, if you don't know, is naming your variables with a prefix that tells you what's in it. And there's two ways of doing it. There's systems Hungarian, which is what people normally think of when they think of it. It's the stupid one. Because you get things like string username, and you'll see in Java like string username. Well, shit. That's what that is. And my favorite, table address. Oh, okay. That table in the database, it's a table. Did you know that? And like prefixing things with like column. Well, of course it is. This one isn't really terribly useful. The one that was more intended when Hungarian notation was put forth is called apps Hungarian, and it's prefixing things with like how things will be used. So we get things like dx and dy because d is typically the delta of something. So this is how x and y have changed. The safe input, one of the canonical examples, or at least the example on Wikipedia, is for safe and unsafe strings. And so an unsafe string would be prefixed with US, so that you know that if you have a US string, that you shouldn't insert into SQL or into a command line, because that'd be really bad, because it's not safe, it's not sanitized. But the sanitized strings would just be S. And so you would know, this is a string that I'm supposed to be able to rely on, and if I can't, well, I'm going to go yell at someone. It's not so good anymore. I mean, it can be useful, but we're writing in Ruby. We're not writing in C. Things have types, whereas in C, they basically don't have any type. I mean, you can say something is an integer, but it's not because you want the type to be integer. It's because the compiler has to know that you only want 2 bytes or 4 bytes or however big your integers are on that system. So we can actually like write out a name, like recent popular posts, and we'll actually know what's supposed to be in there. The big thing is that you need to make sure things are clear. So, making sure things reveal their intentions, making sure that you're being precise. All of the things go into saying what you mean and meaning what you say, like calling an array of users, users. Now, going back to the example that I had at the beginning, the recent popular posts, I think, is actually a fairly decent name for this, because I could have just called it posts, because we're dealing with posts. It's the recent it's the recent post object. Of course we're dealing with posts, but if right here, recent popular post, without having any other context, what this is supposed to be getting. It's getting recent popular posts that we're now going to use on the homepage or something. So I named a library cocaine. I extracted it from Paperclip in order because I was handling the command lines, and so I named it cocaine because I wanted to do command lines. And that right there is exactly the reaction that I was going for when I named it cocaine. Because I'm big into puns like that. The thing is, and while this is a slightly descriptive and at least memorable name, you really don't want to take a metaphor too far. It's very easy to do. And I don't want to necessarily pick on it, but there's a library called VCR that will record. You make a request to a web service and record it, and you'll have that response so that you can make the same request again later without having network connection or whatever, and it'll play it back. But it's like it goes into things like eject cassette and insert cassette, and it's like, well, I think you might be stretching this a little bit, but I mean it's right on the edge because there's nothing too egregious there. But I could have done cocaine.doLine. I don't think this is well named. It's certainly funny, but it's not good. You're not going to be taking this seriously. The pun behind the name originally, attracts attention and whatnot, and I just happen to like it. It needs a name, so let's name it something. Once you're past that, you should name something well, so that people have a good, reasonable expectation of what they're getting into. Finally, we need to document the documentation. So I know I said that having good variable names, good method names, good class names will give you documentation about when someone's going in to look at your code and figure out what's going on. But and it wouldn't be a Ruby conference unless I mentioned testing. But your original documentation, your original feature spec, the original client of your code are the tests. And you do need to name those well as well. So the test name should really be its justification. So unless you can explain concisely and clearly why something is there, it probably shouldn't be there. I mean, I don't think that's going too much out on a limb. So if we have, let's say, a library, we need it to contain a lot of books. So in this case, the library contains a lot of books. And we can see that, yes, this library contains a lot of books. In an integration type spec, or feature spec, acceptance test, whatever you want to call it, we say, okay, the user's visiting the library, and a user visiting the library can reserve a book. And a user visiting the library can reserve a book when, it runs off the end, but when it's already checked out. So in one sentence, we know exactly what's going on here. We know that in this case, or in both of these cases, the users are going to check out a book. In one of these cases, the book will be there, and one of them it won't. They've justified itself because these are actual use cases, and they're clear. You know what's going on, and so this is the kind of thing that I want to see when I look at tests. So names are important. They are how you communicate. They are when you write the code, the computer will just run whatever crap you put in there. But names are important because they're how you think about code and how you relate to your coworkers. It is the interface between you and the computer. It's how you interact with the code, but it's how you interact with your coworkers. It's how you interact with yourself, and it's how you think about things. It's how you think about your domain. So it's not just how you interact with the problem. It's how you interact, or it's not just how you interact with the code. It's how you interact with the problem, and the problem you're trying to solve. But so the big takeaway is reveal your intentions. You need to make sure that what you're doing is upfront and visible, so that everybody knows what you're doing, so that nobody's going to get confused when they come back and read it, including you. But here's the thing. This is hard. I mean, I've given you some tips, but it's still difficult to do. There is no algorithm for naming something. I mean, remember, like if you I can count numerous times where I've just had a problem coming up with a name for a model or a name for a class, and I've had to pull in 2-3 people just to figure out what I should call this concept, because it's important to make sure that the name is good, because I might be thinking of it wrong. And sometimes people tell me that. They tell me that why is this not two things? Or why don't you use this word that actually covers both those cases? Or why aren't you doing this? Because very often people with no context will think of things that you aren't, because you're already thinking in the domain and they're not. So they have the freedom to think of things that you probably wouldn't think of. But so if you ever have a problem with naming things, don't feel too bad, because it is hard. This is a hard problem. It is one of the hardest things in computer science. So don't feel too bad if you can't name something well, but just remember that you really need to try to name things well. Thanks.